Hi, and welcome back to our set of Prespective tutorials. Today I'll be actually showing you the first actual working with Prespective tutorial, which is about working with your mechatronic assembly and in specific the naming and framing part. Let me just check. Yeah. Um, so, what then is naming and framing? Well, basically, you start by importing your assembly, but it really depends on what kind of simulation you're running on how you would want your assembly to be, well, basically formatted. So what we'll be doing this in this tutorial is basically refitting the assembly, in particular the hierarchy, to match your requirements best. But what is important to note here is that the changes you'll make to the assembly hierarchy are specific for your application. So by the grouping we'll be applying later on, we'll still be retaining the linkage with the original CAD file and thus also the structure it originally held. But we'll be refitting it so it's easier to work with. Basically, we'll be turning our assembly into technical Legos. So for this demo, we'll be working with a crane assembly, which is present in the asset pack, which is provided with Prespective. And we'll be introducing several kinematic mechanical relations, the wheel joint, the prismatic joint, and finally also the piston joint. And we'll show some locally controlled mechatronics. So this is basically the first step before you start attaching your logics into the assembly. So let's get started. We'll start by importing the assembly. So here I have my project. It's basically the project I had when which resulted from importing or actually installing Prespective. So we have already Prespective installed in this particular well, empty project. So first we want to import our file, and we're going to work with a collada file. So this is actually an assembly we imported using Pixies beforehand and then exported as a collada file so we could use it from anywhere. So let's select that file. I'm just going to have to go through this particular project, so let me skip there real quick. And inside our Prespective folder, there's a folder with components, so that's plugins Prespective inside your assets folder. And there in Prespective, there's a folder with crane demo files, and there's a crane.step.dae, and we'll open that one. So down here are some settings. Generally DE, but most CAD files are provided in a right-handed orientation. But if you were to come by one in left-handed orientation, you can set that here. Furthermore, after importing, the file will be buffered in your resources folder, so you can set a target folder here. By default, it's resources, but if you would want, you could store it somewhere else. So let's start by importing the file. Okay, so here we have our crane. Um, so it's a basic crane with two pistons and extension part. For this particular demo, we'll be focusing on the lower part of the crane, with in particular the first rotary part and the first piston part. Yeah. So going back to the second step. That's actually grouping the parts that share a mechanical functionality. So in this case, well, it's pretty obvious to see that we have a piston bar and we have a lower part that is actually a rotary fitting for a piston bar. But for us, we don't need to have those in a separate setup. We prefer to have them combined because if we rotate this part should go with it. But what you can already see in this particular assembly is that they don't even share a same parent. This one is solid 167.1 and this is actually solid 161.1. but we still want to have them combined. So for that, we're going to use a specific perspective tool, which is called grouping. And so grouping is actually different from creating a prefab or actually just merging the meshes together, because it's about combining parts that needn't share a parent for a specific uh, thematic, let's call it thematic combination. So to group, we'll go to prepare and go to grouping, and then we get a separate menu, and here we see we can group selected objects. So let's do that now. Okay, so after we press group, you see that there's a logo behind here. So we have created a group, and this is it. We use icons in the hierarchy view to make specific perspective implementations easier to see inside well, basically the inspector view. So right now I just included two parts, and those are visible in here. Now, if I would say like, okay, actually this part shouldn't be in my group, I should also be able to put it back where it came from. So we have that as well, so we can remove the selected object from the group, and now it's already placed back where it came from, which is 1.1, 161.1. But in fact, we would very much like to have this particular part in here, so we'll also be able to add parts to the group after it's been created. So once we're happy with the content within the group, we can also use it to simplify our hierarchy. So we can actually close the group, which is a button inside the inspector view, and you can see the box actually closes. This results in a single packed mesh inside the group, but also it locks the group for selection. So we're not actually able to select this particular part, and that's because well, we don't want you to be able to move the mesh within the group object. Otherwise, it would lead to problems with hierarchy and local transform positions. So for now, we'll just leave it open because we don't need to have it closed. And let's combine some other parts as well. So we got this group, we don't need it anymore, so let's hide it. We can do that here, or we can basically do that there. We want to have this part combines and group that together. We want to have this part, which is actually a single solid, but we're still going to turn it into a group for easy selection. We're going to group this part. We're going to have these combined, which are just some solids. And let's see, did we miss something here? No, I guess not. And let's for a sec hide the groups we have already created. That one is already hidden. Let's hide those two. And this lower part, we don't need to have it separate anyway, because it just contains bolts and a main body. And we want to have that into one singular group. So let's group that one. And finally, we want to have all the rest. We want to have that into a group as well. What you'll see now is that I've actually also selected a group as part of my selection. We don't currently support nested groups. That's for reasons in terms of serialization, so storage. But you needn't be very careful with that, because if I were to press this group selection, it will actually toss a lot of messages telling me that you can't actually group this particular part because it's already part of a group. So this group now only contains the top part of the setup. So that's okay. Okay, so as you can see, our hierarchy has already reduced significantly in complexity. All the parts are still in here, but yeah, we now have it at least set to groups. So let's give these parts a bit more logical names first. So this is going to be let's call it a top bar or something, top body. And let's give this group the name lower body. And these other groups, let's see what they are. So we have here, it's, well, it's part of a piston, so let's say lower piston top, uh, top hinge, and let's unhide the other one, which is actually, so it's a lower piston top piston. And let's show this one. It's going to be the lower piston, lower piston. Not very creative with names today, but it's okay. So lower piston, lower piston. And we got this one, and that's, I guess, the final part, which is the lower piston, lower hinge. So at this point, I need to be very careful with where I place my groups. I can move them around in the hierarchy, except for inside another group, but beyond that, we have total freedom because the groups themselves remain the tie with the original cut file. So if the original cut file updates, the groups will do that as well. We'll show that in a future video. So for now, we have a decent hierarchy. We're not going to do a whole lot with the top body, at least for now. So now we need to go to the next step, which is basically setting the pivot positions. So um, arguably you could say, well, pivots is something that is part of the CAD assembly, but we personally believe that it's actually also dependent on what kind of application you're building. So in this case, we need to have the pivot for this particular lower piston somewhere over here in on the circular part, because otherwise it will not rotate in a manner that is fitting with the piston structure. But if I were to hold it here, I would prefer to have the piston over here. So it's also very application dependent, and that's why we enable you to set it inside Unity itself. So we don't need the group manager anymore. Let's start changing some pistons. So um, having this big assembly is very nice. Having all the parts in there is also very nice. But right now we're just focusing on this particular part. So really what we want to have is this part, only this part visual. So for that we also have a functionality, and it's called isolation. So we'll go to prepare, we'll go to selection isolation, and we'll say isolate selection. And in this view, only this particular part is actually active and visible. And actually I can just press de-isolate selection and everything just comes back. If I am to select multiple parts, like for instance 2 groups, and I were to isolate selection, only those 2 groups are visible, and then I can still say, okay, maybe I don't need this lower part, so I'll just select that and add selection to isolation, and it's also going to be hidden. So for now we just need to have this part visible, so I'm just going to say isolate selection. And we'll leave this window open because we'll be using that quite a lot. Secondly, well, we want to have our pivot somewhere over here. It's now currently in the center of the group. So we'll need a bit of a support object, and for that we'll just be creating a simple cube, a Unity cube, and we'll be changing the size to 1 centimeter in every direction. So I'm just going to put this on 0.01 size, and that will turn it into a cube with 1 centimeter sides. Furthermore, we'll be using our alignment tool. So go to prepare and go to alignment, and let's also add in this tool into a separate window so we can actually have it visible. And this requires us to get 2 parts. So the first part is we have a from part, which is going to be the part that's going to be moved, and part B is going to be the part we'll be moving towards. So for our from part we'll be using the cube, and for our tool we're going to use the transform pivot. So we have several tools. So let's zoom in on the cube. You can either use a 3-point plane, which allows you to use a 3 points on the either on the cube or in world space, and it will focus its center point in the center of this triangle. You can also have a 3-point circle, which will actually create a unit circle around the 3 points and focus on the center point in the exact center. You can have transform pivot, which means it just focuses on the pivot of the regular transform. We can have an n-gon plane, which means we can have any number of points and focus its center point there, or a 2-point line. But most common, and especially for this application, we'll be using a transform pivot for our cube. And secondly, in our lower piston, we'll be loading that into the 2 part, and there we'll be using the 3-point circle. And now comes the big challenge. We need to put our circle on the vertices that are on the border of this particular round part, because that will allow us to see an actual plane that is fitting with the expected center point of our pivot. So to do that, we'll be using the default vector snapping tool that's present in Unity, and a shortcut for that is Shift V. And what you'll see is that there's going to be a cube around your point. So there's going to be a cube around any selection point. And now if I move it, it's going to snap right onto the vertices. And that's what we're going to do. So we're just going to move our 3 points onto the circle. And what you'll also see is that it's actually not on there. It's actually on a different point. And so we'll have to change orientation a bit until we get it exactly right. So going around the shape helps to see if it's on the surface. Also, I prefer to set my my scene mode to isometric at this point, so you can actually see your object. I'll have to set the zoom levels from specific angles, so we can actually see if it's a planar setup. So this seems to be okay. And so we can actually apply this alignment. Now, we needn't set the rotation of the cube, we can just set the position of the cube. So we'll just press apply alignment, and you'll see the cube is now moved to the center of this particular circle. Now, another difficult part is actually getting out of the vertex snapping mode once you get into it. So best is to select any mesh in the world and pressing Shift V again, and you'll see the squares will hide or remove. So I'm not just gonna clear both parts, and we're gonna open a different tool. It's also prepare, and then it's move pivot, and we'll also put that in the window we have opened. So here we'll be able to move our pivot, and basically all we need to do is select the part we want to have as target. So in this case, align pivot to object, we want it to align to cube, and the part we'll want to set our pivot for, we'll just select. Now we can press change pivot, and you'll see the pivot has now changed to this particular position. So this works for groups, but this also works for objects with meshes or just empty transforms. In case of a game object with a mesh attached, it will also change the mesh itself. So it will actually move the vertices of that particular mesh in the space to be able to fit the vertex at the 0 position. So well, let's zoom out a bit, and what you'll see now is that we'll be able to rotate this part around our new pivot position. So that's good. So let's leave isolation mode, so we have all our parts back, and let's set the second pivot. So for this case, we'll need to set the lower piston. Now, we already discussed that we don't currently allow you to have nested groups. So since we'll have a piston part 1 and a piston part 2, which will need to move inside each other, we now want to have this part in with the other one. So at least there. Oh, wrong one. So let's move it in there. Alternatively, I could also create a shared parent. So for now we have a parent object still present here, but I could also use the shared parent function. So I'll just move it back in the hierarchy. And now I can just say, okay, let's select these two parts, go to transform and create parent with or without child rotation. So generally you just want to have it with identity rotation, but you could also copy the first child rotation that's in there, so you maintain rotation. But let's create one with identity rotation. So now both selected parts have been moved into a new parent that adheres to basically the pivot position of the first child it encounters. So this is okay, but we still want to change this pivot. So again, go into isolation mode, and now we can just select new parent and isolate. And we're gonna have to do the same trick again we just did. So I'm just gonna reactivate the cube so we can have something to align with. I'm gonna say, okay, cube is gonna be my from tool. I'm gonna have my 2, which is gonna be this one, which is the lower piston lower part. And I'll have to set the 3-point circle points to match the points that we want. So again, turn on vertex snapping with Shift V, and also make sure you don't have the part selected the part you'll be using the vertices from, because it will respond real weird. So I'm just going to click outside this particular part right now, so it's no longer selected. And now we can just move the vertices onto the edges that we need. So again, for this one, we're using the 3-point circle tool. So this seems to be pretty much okay. So let's apply the alignment. And let's clear both parts so we don't have the tooling anymore. So now I'm just going to select a new parent. Turn off vertex snapping, so click on the mesh and press Shift V again. Select the parent, select move pivot. Cube is still inside the align pivot to object, so we can just use that and press change pivot. So now it's changed. So that we can go back and de-isolate the selection. And we'll have to set the pivot for this part, so the top body. So again, same trick. Go into isolate selection, go into alignment tools, select the cube, unhide the cube so we actually have it visible. Move the cube into the first transform, select the top body, have that one in the second transform, and the first one should be set to transform pivot, second to circle, and let's do some snapping. So I'll just do Shift V, unselect the top body so it's not gonna act all weird, and just place 3 points on the outside of this particular circle. I'm just gonna turn around a bit to see if it's okay, and this seems to be okay. And so we can just say, okay, now we can just apply the alignment. Still I'm in vertex snapping mode, so click the mesh, press Shift V, clear both parts again, and select the entire top body. And this is also a bit of a construction issue. I'm just gonna discuss it now because otherwise we'll have to change it again later, but you'll run into those situations anyway. What you'll see is that there's actually, I'm just gonna de-isolate the selection. This particular part is not attached so much only to the lower piston, but it's actually a child of the top body. So what we want to do is have those two parts, the top body and this particular piston. So let's select those two parts and let's give them a common parent. So let's go and say Prespective, transform, create parent, and well, just have it with identity rotation. It doesn't really matter. So we have those two combined. Because actually this particular parent needs to have its pivot set here. So let's call this one again top crane or something. so it's a bit more logically named. Let's isolate the parts again. And let's go into move pivot. We still have cube selected. Select top crane and say change pivot, and now it's moved nicely over there. And that's okay. So de-isolate again. And let's see, we changed this one, we changed the top one, but we haven't changed this one. So we want to change this one as well. We want to have the pivot over there. So again, isolate selection, unhide the cube so it's visible. Go to alignment tools, add in the cube in part 1, add in the lower piston part in part 2. Use the 3-point circle, and just gonna move the points apart so we can actually see the circle. And use Shift V to snap it. Let's zoom it a bit because this doesn't seem to be right, and under different angles you also see that it's not correct. So this seems to be a lot better. Yeah. So now we have another setup. So we can apply the alignment, clear both parts, and we'll probably still have vertex snapping it set. So click the mesh, press Shift V so we lose it. Go to move pivot, cube still set over here. So we just need to select the part and change the pivot. So that's okay. Okay, so then de-isolate the entire assembly again. So now we have this part set, we have this part set, we have the entire top crane set, we have our lower, well, let's call this one lower piston then, because otherwise it's going to be difficult to explain. So we have basically all the parts set. Maybe you want to also be able to move the entire body, and that's okay. This pivot actually seems to be pretty much okay already, so we'll just leave it there. And then we have the final setup. So I guess that's basically it for structuring the part. Yeah. So let's add some wheel joints. First, what we'll need to do is add in a kinematics controller. So we don't need the isolation stuff anymore, so we can close this window. And that's in prepare kinematics, add kinematics controller. So we need only one controller at the top of our kinematic hierarchy, and it will actually allow us to also activate the kinematics in editor mode. It will also automatically index new pistons or new kinematic parts, so we needn't really do anything with this for now. So let's add a wheel joint here, which is going to be the bottom one. And so we'll go to either add component, or we can just go to again prepare kinematics and add wheel joint, and we'll see a blue outline of how the joint would look. So this is the basics of creating a joint. We'll just add the component. And by default it's set to a single meter in diameter. But yeah, we don't need to set that at this point. Also, this particular joint doesn't have a limit, so we needn't set a limit at this position. What we can show you is how it would work in play mode. So I'm just going to turn on enforce outside play mode. And now if we are to rotate the part, you'll see that it actually shows you how far it has rotated. So we can just affect it using the Unity gizmo. And if we're done with it, we can just turn it back, set the rotation state back to 0, so we actually keep our base state. So that's actually the first wheel joint. We don't need to do much else to this particular wheel joint. It's okay. We might change the actual size of the radius. So let's put that 0.5. So that's half a meter, or maybe even 45 centimeters in radius. So at least it's not in the way. Also, once you've add kinematic components, it will show these green icons. So the first one is indicative of a kinematic component rather than a physics component. So that's about absolute motion rather than physical motion. And the second one shows a rotary indicator, which means wheel joint. So next one we need to add a wheel joint here. So we have the lower piston, and we can just use add component as well and just type in wheel and you'll see wheel joint. What you'll see now is that it's actually not aligned properly. The axis direction is wrong and the forward direction as well. Actually, we want to have those inverted. So what we can see here is that the local parent up direction, which is the axis direction, is actually the one we want to have for the forward direction, and right is actually the one we want for the up direction. So let's just swap that around. So we have right and we have up, and now once we move back into scene view, you'll see it's been rotated around. For this particular joint, um, well, you might want to add in some limits. For now, limits aren't very important because we're gonna add in a piston system anyway, but we can just show you how it would work. So let's add in a limit, and now you'll see that there's just one line left. So this means there's actually no space for this wheel to move. It's from 0 degrees to 0 degrees. So let's say it's minus 40 to 40 degrees, and you'll see now what the effect is of the directional change. Also, you might want to say that, okay, the actual forward direction or the 0 degree position of this joint is in line with the piston. So you might want to use a gizmo for that. So that's actually the forward direction. So we'll use the scene gizmo in the forward direction. Now I'll get this gizmo over here. And let's align this neatly by using vertex snapping. So I'm just going to put on Shift V again, and you'll see it's going very aggressively into the system. Let's see. Let's say somewhere over here. Seems to be okay. So now the 0 position for this particular wheel joint is now aligned with this particular direction. So our offsets, so our limits, now also relate to this particular direction. And you can also use this to create non to affect the planarity of your setup. So this is, I guess, okay for this particular wheel joint. Let's set the second limit a bit further. So our maximum limit, we're also going to use a gizmo for that, and just drag it over here and set it to, I don't know, 229. That's okay. We're never going to get there anyway. Again, so this piston is pretty much complete. And then let's add our third piston, which is going into our lower piston, lower hinge, whatever. Well, let's just do it here. Add a wheel joint. Again, see that the settings are correct. So for this piston, it doesn't really matter what the forward direction is, as long as the axis direction is okay. So that's the green line. And let's make it a bit smaller. So let's make it 5 centimeters in diameter. On the top body, top crane, we'll also be adding a wheel joint. Do the same to that one. So say we want to have it 5 centimeters. See now that the rotation is actually wrong. So we'll swoop the forward and axis direction. So this is right, this is up. So we're going to set this one right, and we're going to set this one up. So it's actually aligned properly. And let's see, add in a wheel joint here as well. And that's gonna be, again, 5 centimeters in radius. And also swap around the axis and forward direction. So this one's gonna be right, and this one's gonna be up. Again, you'll see it matches nicely. So let's see if we have all our wheel joints. We have one at the bottom, which is going to be the rotary system for the entire crane. We have one over here. We have one over there. We have one over here, and we have one over here. So that's 1, 2, 3, and 4, at least part of the system. Okay, so that concludes the addition of the wheel joints. Next, what we'll also need is a spline. And this is because we'll be adding in a prismatic joint. So a prismatic joint is a joint that is only allowed to move over a particular line. So in this case, we'll just need a linear spline because we need to put something on the piston to make sure that we're only able to move our piston inside the, well, barrel or what you want to call it. So to add a spline, we'll just say Prespective, spline, and create spline. And that'll just create a new spline down here, and it's always just 2 points positioned at the origin and 1 meter. And well, we can move the points around by just selecting them, and this will also change the line. So if we want, you can create a very complex spline by just adding in different points. Let's show that now. So now we just inserted a point and copied it back into the center. And what you'll see also is the green line, and this green line is actually descriptive of the normal direction on the spline. So what is important to know is, and we can also visualize that, if we show the local coordinate system of your spline, and you can do that by selecting a control point and setting the show normal x, y, and z axis. A spline always follows its forward direction in the direction of the line. So in this case we have point 1, point 1, and point 2. And so point 1 will have its z-axis aimed at point 1, 1. Point 2 will have its z-axis aimed off the line, so it's just an opposite direction. And point 1, 1 will have it aimed basically from point 1 to point 2, because it's like in a corner. But a line generally does not have a up direction, but we'll need that to be able to lock our prismatic joint into position. Without an up direction, we wouldn't know what axis to lock it onto. So by default we show a normal direction as a green line on top of the spline, but if you feel like you don't need it, you can just turn it off by setting the show spline normal line off in the spline main script. Also, if you feel like turning the splines into a different color, you can just select a color that is perhaps more contrasting to the color you want to have. And finally, you can also mess around with the spline a bit and just say like, okay, I want to have a continuous line, and then it will just generate a spline with continuous line points, so you can have a nice ease in the line. And that's important for creating more complex shapes. So in a future tutorial we'll also show you how to create a belt system, so a moving belt system, and that makes use of a loft based on splines. So we'll show a bit more complex spline functions in there, but for now we'll just use a spline consisting of 2 points. So I'm just going to delete this particular center point. We don't need it for our application. What we do need to do is actually snap our spline onto the piston. So let's set ourselves up in front of it. So I believe I have actually rotated my crane a bit. Yes, I did. So I'm just going to turn this one off and rotate it back so it's easier to align. And then turn it back on. And we're just going to snap our points onto the lower part of the piston. So I'm just going to select that part and say point 1, turn on vertex snapping, and it's always a bit of a hassle. And just put it on the exterior of the piston system. Now what we can use is actually that the green line should be somewhat aligned with the points if we do this right. So I guess this is pretty much okay. Let's look at the shape. Are we happy with it? I guess we are. Also, let's turn off the z-axis on the line points because we don't need it. And this is okay, but I see that we actually put the 0.1 on the wrong system there. And now I guess if I were to, yeah. So if you've done this correctly, you'll see that the green line and the red line will actually overlap. And that means it's actually exactly focused on the z-axis. So for our piston, it's gonna be just fine to use it like this. Now we're pretty happy with our spline. Let's turn off vertex snapping. So let's click here and then press Shift V, and it's gonna go into the piston. So let's put it in the piston, the lower piston. What we don't want to have is that we're actually working halfway and we might actually accidentally select either the spline or one of the control points and start moving them around. So from now on we want to have this spline locked, and for that we'll be adding in a lockable transform. So that's, we go to Prespective, Transform, and create basic lockable transform. And this will also create a locking icon next to it. You also see the same icon with the groups, and that's because we've added in locking automatically. So if you close a group, so if I close a group, we'll also lock the children of the groups into the position, so you can change anything you're not supposed to. For a spline, we'll have to do that manually, and we can also select what we want to have locked. So the basic lockable transform, we have that over here. Let's lock the position locally, let's lock the rotation locally, let's lock the scale locally. Also, let's prevent us from being able to select anything when multi-selecting. So when I'm drawing a line over here, it's actually going to prevent me from selecting any parts that are within it. So let's do that. Select nothing when multi-selecting, and hierarchy locking is not yet implemented. For now, also lock children. Yeah, we want to lock ourselves and our children so we don't have any problems. And now you can test this just by trying to select 0.1. And when you select that, it will actually move the selection pointer back to the spline because, well, we're not allowed to select this point. We've added in a temporary debug message showing you that 0.1 was blocked since they are locked by the parent. So if you ever run into behavior where you can't select a part, it's probably because the object is locked by a basic lockable transform. It should be visible as a blue lock in the hierarchy view, a locked lock. But if you have trouble finding it, you might also want to check your console. Okay, so that's it for the spline. We don't need to do anything with that anymore, but we will need to add in a a prismatic joint on our lower piston, top piston. So select that one, add component, or no, let's just go over here. Let's go to prepare, let's go to kinematics, and let's say prismatic joint. Now, what we need to set is a constraining spline. And let's add that in here. And now it's already ready for operation pretty much. So let's also turn on enforce outside play mode, and this might be affected a bit by your offset. Let's see. Yeah, so min response size is 1. Now, if it's part of a kinematic system, then it should already work. So let's see if that does. Oh yeah, I actually forgot something here. Preferably we want to have our center point somewhere in between those 2 points to make performance best as possible. So we'll also need to change the pivot on our lower piston, top piston part. So let's do that first. Let's turn off, well, let's just remove the entire prismatic joint. And let's go into isolation mode again. So prepare, selection, isolation, isolate selection. And let's move our pivot to the lower part here. And for that we'll use our alignment tools again. We'll use our cube that's somewhere floating around. Set the cube, set it to transform pivot, select the lower piston, and let's use the 3-point circle, and let's move. Oh yeah. And let's check if it's okay. That seems to be pretty much fine. Let's apply both position and rotation, and let's so it's already also rotated in the right direction. We can just close this window, we don't need it anymore. For now, disable vertex selection by pressing Shift V, go to move pivot, select the cube, and select the part we want to have moved, so that's going to be lower piston, top piston, and let's say change piston pivot. So that should pretty much cover it. So let's go into the lower piston. We still have our spline. Actually, we need to de-isolate everything for a sec. And let's try that again. So I'll just add a prismatic joint. Add in the spline. And let's see if now it works. So now it actually only allows movement within the range of the spline. I'm just going to use Ctrl Z to get it back to its original position, but the first thing we want to do is have its limits somewhat fixed a bit further. So I happen to know that if I move it back somewhere over here, that's going to be pretty much the maximum offset we're going to allow. So let's just set the limit for 0.2. So while having the piston and the prismatic joint selected, go to target control points, set it to 0.2, and what you'll see is that we'll actually be changing the spline. So we'll say update limit control points. Oh, and for that I need to actually unset the locking on the spline, otherwise it's not going to work. So like that. Um, let's try that one again. Update control points, and then move the spline, actually the piston upwards until we feel like it's pretty much on its maximum. That's going to be over here somewhere. And let's say 0.1, update limit. So that's pretty much it. Like that. So now we have a prismatic joint and a wheel joint. So fix that. So we just need to add in the piston joint. To do that, we'll need to have something up there, and it should be tied to this particular part. So let's give this one a parent. Actually, let's change it around a bit. So let's remove. No, let's keep that one. Let's add a parent transform with child rotation to this particular part, and let's move the prismatic joint to that particular parent. This is always a bit of a dangerous thing to do because there might still be some residual settings in here, but I guess we got it working. No, we didn't. No, actually it does. So we moved the piston, actually we moved the prismatic joint, and we'll be adding a empty game object here. And I'm not going to be very precise with this one. If you're doing this with your actual system, you might want to use a actually let's do that anyway. Let's use the alignment tool again. So we'll go to prepare alignment, select the cube again because we're doing that anyway, transform pivot, and let's select this particular part. No, that one. Yeah, so we need a solid. Let's add it in there, and let's say 3-point circle. And actually, I guess we could use isolation mode right now. There's a quick isolation mode selection over there. And let's do some vertex snapping. So let's move it to the corner positions. Over there. And that seems to be pretty much okay. So let's apply the alignment. And we just need to, let's set position and rotation. Doesn't really matter anyway. And let's close this window. And let's change the pivot of our empty game object that we just created. So let me just think. I guess that's this one. So that's going to be, I'll just call that piston target for easy reference. Let's say move pivot, select the piston target, select the cube in here, and let's change that pivot so now it's neatly aligned so we don't get any problems. So this is going to be our piston target, and for that we'll also be adding a piston joint. And the piston joint actually requires you to do a couple of things. First off, it needs you to add triangles. Like it says, must implement a triangle. So these triangles are always based around a singular arm towards a wheel joint that is either rotary and static in length, or static in position and static in length, or dynamic in length with or without a prismatic joint. So let's set that up. So let's add a triangle, and now it expects me to add in a wheel joint and another wheel joint. So we're gonna lock this particular part in the inspector, so that's gonna make sure that it doesn't get deselected when I start looking for wheel joints. The first wheel joint we'll be adding is this one. Actually, I see I've kind of messed up my the alignment of my yeah, well, it doesn't really matter anyway. Let's first set the normal direction of our piston. So it should be in the same direction as, I'm just gonna be real mean on this one and move my piston target manually. I bet you guys can do the alignment, but not at this moment. So, and we'll have to set the normal direction to match the normal direction of all the wheel joints that it will be attached. So the green line needs to be same directional. So select piston target, select the, I guess, right axis. Oh, that was, yeah. So it's following the right line, the red line, so that's right, and that's okay. And let's add in the wheel joint. So the first one is going to be, I guess, this one. And then we have another one down here. So that's, I guess, lower piston. And now we get some extra options. So it's going to draw a triangle on top of, well, let's choose a color that will actually show up a bit. It's going to draw a triangle on top of the where the piston is going to be, and it actually has some icons on it, and these match with the settings we do here. So point A is over here, point B is over there, and point C finally is over here. So first thing we want to do is set the first to A to B direction, which is the first one, self to wheel joint arm type. And it's actually rotary, but it's static in length. We can change the length of this particular hinge segment. So what we need to set is rotating arm, but static length. And that's also going to change the icons, and I hope you can see it over here, to a double triangle, which is indicative that it's actually movable. Then the second part is actually static in length and static in position, which is what this icon references towards and is okay. So fixed static length, we can leave that there. And the third part is actually we're using a prismatic joint. So we'll say dynamic length and prismatic. And now it will also prompt us to add in the prismatic joint we have over there. So let's put that in there. So that's the first triangle. Then we have actually a second triangle, and having two triangles actually prevents, in most cases, flipping of the piston. You needn't necessarily add it, but for now we need it because otherwise the top arm wouldn't move. And it's gonna be between this wheel joint, that wheel joint, and the piston target. So add a triangle, and it's gonna be over here. Open it up, and let's select again the wheel joint. So the first one is going to be over here. It's going to be top body probably. No, that's the last one. Well, let's add that in anyway. And this one, which is top crane. Yeah, so we need there. So we have top crane and lower piston, and it's also going to show us a triangle. First axis, so from self to B, is actually dynamic in length, but it does not contain a prismatic limit. So we'll say dynamic length and implicit. Then we have an axis that is actually fixed in length and cannot be rotated, so that's okay like this, fixed static length. And the third axis again is static in length but can actually rotate, so it's going to be a rotating arm and with static length. So this actually is our basic setup for our joint. And now we need to add one more thing, and that's actually a relation between the piston and the prism and the piston. And we'll do that next. So this is actually still a temporary thing. We'll fix that in the next update. But we'll add a leading transform, actually a trailing transform, in here manually. So let's go to the prismatic joint, and let's go into trailing transform, set that to 1, and we'll have a bidirectional translational relationship between the prismatic joint and our piston target. So all we need to do now is pull the piston target into the target kinematic transform, and that should pretty much do it. Now, as a final checkup, I always check whether I have all my wheel joints set into enforce outside play mode, so we don't have any problems. So this one is still not on. That one is still not on. This one is already working outside play mode. We have the top crane, which is not yet on, and the lower piston, which is also not yet on. The safest way of testing your setup is generally just doing it in play mode itself, because then you don't risk destroying your setup. So now we're running, and we should be able to select the prismatic joint and move it up and down. And what you'll see is that our crane will now move with it in a correct fashion. So that's nice. Notice that there's still some glitching in here. That's basically due to the update cycle that is tied to the gizmo that you'll use in Unity. But if you're doing this with a function, like you're doing this by code or using a controller system, then it will not have this particular glitch in there. So this is the basic working of our piston joint, and also outside play mode it will also work, but be careful. Sometimes you may actually already mess that up. Something is still, oh wait, yeah, our piston target is not yet working outside play mode, so this should, yeah. So this will also work, but be careful. You might lose some settings if you use it too aggressively. So that's the basic setup we have. So we have a crane, we have a rotary joint on the bottom that controls its horizontal direction. We have several wheel joints that fit around the piston, one with a limit, but it's not necessary. Um, and finally, we also have the piston itself. So that's this one. As a final action, you might want to close your groups. This has no real effect on the scene itself, but it will make your contents or actually a hierarchy a bit more manageable. You can always open your groups later on, and if you're afraid that someone might actually break into your assembly or damage something, you can also remove the group script, and it will actually remain packed like this. So that's a way of protecting your data. So let's close up all the groups. Finally, this one. And now we have quite a neat little setup that will do its basic mechanical work. So finally, we're going to add in a stepper motor. Now, a stepper motor is basically already a logical component. So generally, you would add a controller, a PWM system to your stepper motor. But from a mechanical perspective, it's already interesting to see what would happen if you would set it up in a particular way. So that's just to see what the mechanical limits would do. So in here we have a rotary joint, and we're just going to add a stepper motor. So let's do that now. So let's add a stepper motor. Initially, sometimes it finds the wheel joint, sometimes it doesn't, but generally it's good to check. Here in properties you can set it tied to a wheel joint. Also, here's the motor step count, and that actually means that we have 200 steps for a singular full rotation of the joint. So step count is really something that is mechanically defined inside your stepper motor and is defined by the hardware you're using. Having less steps means each step will be bigger, and that will mean a rougher motion generally. So the default stepper motor, let's say your budget stepper motors are around maybe 200 steps. If you go beyond that, it's generally very expensive, but rather you're simulating having a transmission system in there. So basically having a set of cogs in there that will actually change the transmission. So let's up our step count to let's say 500. Doesn't really matter that much. We'll have a maximum angular velocity of 100 degrees a second, angular acceleration of 50 degrees a second. We don't need an offset in degrees. And let's go to the control panel. So here we have the preferred angular velocity factor, which means the factor of angular velocity that is allowed. Generally setting it to 0.5 is okay, but it also depends on the hardware you're using. Here we'll have a rotary target point set. Basically this is something that will be set by the control software, but to prototype our system we'll set it to well, let's say 120 or 250. Yeah, 250. So this is actually the amount of steps we'll be taking. So in our system, we now have basically a 360 degrees setup divided by 500 steps, and we'll want to move 180 degrees or at least half of the steps. So that's 250. We want to move in an absolute rotation, and we want to move in clockwise direction. And this should already be okay to show you a bit of, well, let's call it animation. So let's go into play mode and let's start the system, and it will actually move to 180 degrees. Yeah. And note that there might be a bit of an offset in here, but it's still due to the floating point issues. We're working that out of our systems. So now we can also set it back to 0, but then we need to, well, we can move both directions, doesn't really matter. And we can just say start. So this will give you an idea of how your motor will move once it's controlled by control software, and also allows you to already run some rudimentary testing. Okay, so that's our first stepper motor. A second one is gonna control the piston. Now this is not very realistic because pistons are generally controlled by hydraulic systems, but we'll just say that there's a I don't know, a cog system down here, and it automatically translates onto a wheel. So we're gonna create a fake wheel joint. So it's gonna be a box, and let's set the box to maybe 1/10 of a meter. Let's move it somewhere that's out of the way. And let's move it into the first layer of crane for truck. So it will move in rotating with the setup. Also, we'll be adding a wheel joint. Or actually, we can just add a stepper motor and we'll add a wheel joint itself. And this wheel joint will actually feed into the piston once it's rotating. So to do that, we'll have to target it as a trailing transform relation. So here we have the wheel joint, and we'll add in a trailing transform relation. It's going to be bidirectional because, well, if the piston reached its limit, it's not going to run idly. It's going to prevent our wheel from rotating. So let's try that now. Let's add the piston, or actually the prismatic joint, I'm sorry. And this will already work. So let's do a quick test. Actually, we need to turn on the wheel joint, of course, otherwise it's not going to work. And as you can see, rotating it now will already affect the motion. So this is a translational relationship. What it means is, imagine there would be a wheel here with a radius of 1 meter, and it would be neatly placed against the moving bar of the piston. By moving the wheel joint without considering friction or drag, it would actually be able to move the piston upwards and downwards. Um, so that's okay. So let's move it back to 0, and let's go for a set of rotations. So here we're gonna say, okay, 200 steps is gonna be maybe a bit low. So let's go to 1200. These settings are fine. And let's say we want to have a rotation point of, well, let's go beyond its limits. Let's say 360. No, let's say, no, we'll have to say 1200, of course, because 1200 steps means 1200 steps per rotation. Let's say rotate absolute, let's say clockwise. So let's go into play mode and let's start up that particular motor. So let's move this part rotating. And I think I actually forgot to tie the wheel joint system. Let's see what I forgot. Oh, yeah, of course. Without an angular velocity, it's not gonna rotate at all. Yeah, so let's do that again. And let's press start to see what happens. Now it's gonna do its rotation thing, but it's gonna run into its final point real quickly. And what happens now is that the piston actually reaches its endpoint. It's no longer allowed to move any further. So it's gonna say, basically it's a one-on-one connection. So it's gonna tell the wheel joint, okay, you're no longer allowed to move. And that's actually gonna tell the stepper motor, hey, we're going into error state. So right now, we're no longer allowed to move any further. And also starting it will not do anything because it's in error mode. So we can reset the error and then try to move it further, but it's not going to allow us anyway. What we can do, of course, is rotate the other way and see if we can get to 1200 that way. So let's reset error. Let's start moving into the opposite direction. So wait, no, actually, I guess I have to do something minus 300, maybe. Reset error and start moving in that direction. And that's gonna work. But remember, we are dealing with mechanical limits. So if we're going outside the range that we're allowed to go, then it's actually gonna run into problems. It's actually going to be unable to move. So now we've moved 300 steps in negative rotation direction, so that's pretty much done. If we go much further, I guess if we were to go minus 500 and start up again, then it's going to run into its limit again. So now we've hit another error point because we're not allowed to move any further. So this is good for aligning your stepper motor systems with the real world systems, because you want to have them tied together. So I guess here we have a range of about, well, I don't know, maybe 600 steps in either direction. Reset error and then start it up again, and let's move the other way. And of course we can move both the crane and this system to both together, so we can also show more complex motion at the same time. So this somewhat concludes the demo we can give you with our kinematic system up to this point. I hope it was educational, and hope to see you next time. This particular scene will be added to the prefab, or actually the asset pack, for you to test without having to run through all the steps. So that's good, I guess. Okay, goodbye.